Okay. Now common collector. I told you we are not going to see common collector in depth, but as a part of seeing the input and output characteristics, we'll be seeing it again. So common collector, you see, the collector is grounded. First, as you hear the name common collector is grounded. So collector is grounded. Only two terminals remain: base and emitter. So base will be input, emitter will be output. So as soon as இங்க பாருங்க emitter side you have this arrow mark, right? So this indicates emitter. So emitter side and base side you put two ammeters. The IB will be in microamperes and IE will be in milliamperes. And you know this base is P type, emitter is N type, collector is N type. And you know that emitter base junction is emitter base junction is forward biased. Okay, forward bias na P type ku positive, negative is grounded. And here you measure since it is plus minus in the battery, this voltmeter is also plus minus. Direction paranga, same direction. And collector base junction is reverse bias. So collector is N. So I'll be giving positive of the battery. Negative, I'll be giving it here. So here you see the battery is upside down. So this voltmeter is also upside down. Any doubt in the diagram? See, till drawing the transistor, grounding, adding ammeter, everything will be as usual. How to draw the polarity on the depends on NPN mark பண்ணிட்டு remember emitter based junction is forward bias. So இங்க base only தான் இருக்கு. Give the connection for base. Automatically negative ground பண்ணிடுங்க. Here collector based junction is reverse bias. Only collector I have. For collector you give the appropriate voltage and negative voltage you close the circuit like this. Don't worry about emitter. Any doubt in the common collector configuration? See, again, I see the diagram la நீங்க வந்து ஓனா வரைஞ்சு பாருங்க. You will be understanding it very, very clearly. And நீங்க ஏன் ஒரு rheostat மாதிரி போட்டு கொடுக்குறாங்கன்னா, the total voltage, whatever you apply, the fully it is not going into the circuit. Only a part of the voltage will be going into the circuit. And the part of the voltage are VEC and VBC. ஏன் VEC அப்படின்னா measuring between emitter and collector. ஏன் VBC னா measuring between base and collector. And here we will not be explaining so much input characteristics. Input characteristics now what versus what we'll be drawing for common collector. Can anybody say input characteristics? See the input side, what voltage, what current you have.
VBC and IB.
Very good. VBC and IB. See here VBC and IB. So as you increase the output voltage, you get graph like this. You get straight line like this. So this is the graph you get for common collector configuration input characteristics. Okay. And this in the graph we don't have reason. So this is all measured graph experiment. In the experiment, whenever you come to college, you will be doing all these experiments manually. You will observe that you will get the similar graphs like this. Okay. So remember all these plots. You have to remember all the 6 plots. 3 input characteristics and 3 output characteristics for common base, common emitter, and common collector configuration. And output characteristics பாருங்க, output current, output voltage versus output current. Output voltage is VEC, output current is IE. At constant input current IB. So in the graph, output characteristic graph வந்து எல்லாத்துக்குமே சேமா இருக்கும். You can see that the output characteristic will be the same for everything. And this region, you know it is cut off. This region, you know it is saturation. So this entire region, this one is going to be the active region of your transistor. So இங்க specific mark பண்ணல, but I am saying you in advance that any graph below 0 microamperes is cut off. Cut off no current. The transistor is the switch is off. Here you have heavy current, so the transistor switches on. It is a short circuit. And anything the region which is bounding the two regions, cutoff and saturation, is called as active region. Only in the active region, your transistor will work as an amplifier. In the common collector configuration, we will not be using it as an amplifier. Because it has see the current gain HIC is very good, but voltage amplification is very poor. It has a voltage gain of 1. So எப்படி காமன் பேஸ்ல கரண்ட் கெயின் ஆல்பா வேல்யூ 1 வரும்ல, அதே மாதிரி இங்க காமன் கலெக்டர்ல the voltage gain is 1. So mainly, even if amplifiers don't amplify current, they have to amplify the voltage. That is a preliminary requirement. But here, since that preliminary requirement itself is getting not satisfied, the common collector configuration will not be coming under the category of voltage amplifier. It will just amplify only the current. And a current amplifier for me, it is not going to provide me any result, because ultimately everywhere I'm going to measure only voltage. So since that voltage amplification is not possible using a CC configuration, we will not be considering CC configuration as an amplifier. It is just like a another configuration only. And this is the comparison. Common base. See here, input resistance, common base, it is very low. Common emitter is moderate. Common collector is very high. Common collector input impedance is very high. But drawback in voltage gain illa. So I cannot consider common collector as an amplifier at all. See the output resistance, it is high. It is moderate. It is low. See, input resistance and output resistance should be very high for any amplifier, because then only input resistance should be very high, output resistance should be very low. So only when the output resistance is very low, it can transfer the entire current from itself to the load. So the condition is satisfied only by common collector. Paranga, input resistance is very high, current drawn is very less, output resistance is very low, current given is very high. So effectively, maximum current should go to your load. That condition is satisfied only by common collector. But on the common collector, see this point voltage gain, it is less than 1. In the property, all the good qualities of common collector amplifier cannot be used. Current gain paranga, common base it is 1. Common emitter it is high. Common collector it is high. Voltage gain, common base it is very high. Common collector it is very, very high. Common collector paranga, it is less than 1, which is a serious drawback for me. Phase shift, common base no phase shift, 0 or 360. Common emitter 180-degree phase shift, because you see that you give a sine wave like this, you get a sine wave like this. There is 180-degree phase shift. So இங்க maximum வரும்போது இங்க minimum வரும். இங்க minimum வரும்போது இங்க maximum வரும். Here also you have no phase shift. And application பாருங்க, high frequency circuits amplification. This is for audio frequency, and common collector is used for impedance matching, because the gain is voltage gain is 1. So very, very important application of common collector amplifier is impedance matching. But these two amplifiers, CB and CE, are used as amplifiers. But the CC is used only for impedance matching. Okay, so I think with that we have summarized all the properties of common base, common emitter, and common